Hey everybody, welcome back. It is 10.2. Today we're going to be starting our lessons on special right triangles. Special right triangles. And the first one we are going to be talking about is going to be a 45, 45, 90 degree triangle. There's certain rules to special triangles. The first one again, 45, 45, 90 degree triangle. Tomorrow we're going to be talking about 30, 60, 90 degree triangles. What properties and what theorems do we know about them? Okay, so we are going to be finding the side lengths of a 45, 45, 90. Very first thing I want you to do is please write this down. There's not many notes today. There's about 3 slides. 3 slides only, so once we get through that, we're done. Okay, in a 45, 45, 90 triangle, both legs are congruent, and the length of the hypotenuse is the length of a leg times the square root of 2. So because we have two 45 degree triangles and a 90 degree triangle, we do know that we have an isosceles triangle. So those two sides are going to be the exact same length, based on, if you remember way back to chapter 4 when we talked about isosceles triangles. That's your base angles theorem. You might want to remember that, your base angles theorem. Alright, so if you take your leg times the square root of 2, that automatically gives you your hypotenuse. So instead of going into your Pythagorean theorem, all you really need to know is one leg, or all you really need to know is one hypotenuse to figure out what your legs are. Alright, so we're going to do a couple examples. First one, again, find the value of x. This very first one, we notice that it is the hypotenuse. Even on the second one, it is the hypotenuse. This is 1, this is 2. Using that note that you just wrote down to, in radical terms, try to find the value of x. Not in a decimal, in radical terms. Alright, so looking at this first one, you will notice that we know a leg. And when we know a leg, that's all we really need to know. Okay? Because if you remember, our hypotenuse is equal to our leg times the square root of 2. Well, if we know our leg, we already know our hypotenuse. Plug in 8 where you have leg times the square root of 2. So our answer is 8 times the square root of 2. And that's it. You leave it at that. You just plug in, you know you need to take your hypotenuse is equal to your leg times the square root of 2. You plug in your leg and you leave it at this. Don't get it as a decimal when it says just solve for the value of x. We'll get into decimals later. Second one, same idea. What do you think x is? Yep, x is going to turn out to be 5 times the square root of 2. Again, going back, you are going to have your hypotenuse is equal to your leg times the square root of 2. Well, plug in your leg, which is 5, and multiply it by the square root of 2. And we can leave that as it is. Okay? Questions? Concerns? Otherwise? Alright? Last slide. The very first thing you do, there's 2 steps to this problem. Very first one, you need to show that the triangle is a 45, 45, 90 degree triangle. So you're going to use theorems that you know from previous stuff. Again, we're getting back into our theorems. Okay, so then once you have that, you're going to find the value of x to the nearest tenth. When it says this, find the value of x to the nearest tenth, that is asking for a decimal. Okay, if you go back to that last slide, it just said find the value of x. You can leave that in radical terms. This one says to the nearest tenth, and when it says to the nearest tenth, you actually break it down and you multiply it times your square root of 2 or divide by your square root of 2. Okay? So, how do we know that this triangle is a 45, 45 degree triangle? Well, if you look at this, we know that x and x are going to be equal to each other. So, because, and this is your reasoning behind it, because what theorem? Our base angles theorem, yep. Our base angles theorem. This is an isosceles triangle. Okay, so all we need to know is those two lengths. We see the two lengths are equal to x, an isosceles right triangle, because we do have a right angle. Alright, whoop, forgot how to spell. Look at that. I've got horrible handwriting. Horrible. Okay, now we're continuing on here, look at this, now we need to get to solve for x. So when you plug this stuff in, again, if you go back into your formula, hypotenuse is equal to your leg times the square root of 2. Well, if we know our leg, we know our square, we know our leg, we know our square, we know our leg, and we know our hypotenuse, because we are given 5 and we're given x. Well, from this point, how do you get rid of that square root of 2? Well, what operation is happening between the x and the square root of 2? It is multiplication. We need to take the opposite and divide. So when we do that, we are going to get x is equal to, x is approximately 3.5. Okay, so rounded to the nearest tenth, x is approximately 3.5. Okay, now what I want you to do is use that same idea. Okay, it's going to be a little bit different of a theorem on this second problem. What I want you to do is give that one a shot. I'm going to erase here and we're going to start all over on this second one. Alright, give her a shot. Alright, so now looking at this second one, you have to first figure out, show the triangle is a 45 degree, 90 degree triangle. So how do you know that? Well, if you look at this, we know that this is equal to 90. We know that this one is equal to 45. So what does the other one have to be? It has to be 45. How do we know that? Because our triangle sum theorem tells us. So our triangle sum theorem, and again, you have to show that the triangle is a 45, 90 degree triangle by an explanation. Okay, so triangle sum theorem shows the third angle equals 45 degrees. That right there gives me a good enough definition to figure it out. Now we need to solve for x. Okay, again, using that same formula, hypotenuse, get this memorized for 45, 90 degree triangles. Hypotenuse equals leg times the square root of 2. Plug in your leg, plug in your hypotenuse. 9 is equal to x times the square root of 2. Same idea. How do we get rid of that square root of 2? We need to divide. And because we are finding it to the nearest tenth, we don't need to simplify that radical on the bottom. So x is going to equal approximately, what do you think it is? I hope you said 6.4. Whoops, wrong utensil. Okay, 6.4 is our answer, approximately 6.4. That's all I have for today. All right, I'll see you tomorrow.